Today we're working on 4.2, and it deals with multiplying and dividing square roots. So we'll start out with this one. Anytime you're multiplying square roots together, you multiply outside times outside and inside times inside. So in this case, the outside of both of them would be a 1. So the outside would be 1 times 1, and the inside would be 10 times 5, which is the square root of 50. And then we factor that and look for pairs. We have a pair of 5s. That comes to the front, and a 2 left over. So 5 root 2. Colton, you might not want to use your phone. That hurts your grade. Okay. Is that any of you guys? If you're in B2, go ahead and go. Sebastian was just confused. Oh, all of you were? Oh, all right. Okay. Here we have the square root of 78 divided by the square root of 6. So that's the same thing as the square root of 78 over 6. So square rooting them individually is exactly the same thing as square rooting the entire fraction. And then 6 goes into 78, 10, 13 times. So this is 13. So I get the square root of 13. And when I go to factor that, 13 is prime. It doesn't have any factors. So the answer is just the square root of 13. Okay, it does get a little bit more complicated than that. Two divided by the square root of 5. Now, you might think that this is as simple as it gets, but whenever we have a fraction like 6/4, there are an infinite number of ways to write 6/4. So to make things less complicated and to make sure that everybody gets the same version of the answer, we tell you to simplify the fraction, which means pull out the common terms. Both of these numbers, the numerator and the denominator, are divisible by 2. So if we divide by 2, I get 3 over 2. Okay? And that's just something we do to make sure that we get the fractions as simple as possible. Well, there are also rules for simplifying square roots, like pull out all of the factor pairs on the inside. But another rule is never leave a square root in the denominator. So we need to fix this so that there's no square root in the denominator. And it turns out there are an infinite number of ways to write a square root. So one of the rules is never leave a square root in the denominator. So how do we do that? Well, we're going to multiply by some number that will remove that square root. Yes, you multiply the bottom by itself. Okay? But if I just multiply the bottom by the square root of 5, I will change the value of the original fraction. So what number can I multiply by without changing a number's value? What is the only number that doesn't do anything in multiplication? 1. So I need to turn this fraction into the number 1. And I have to have the square root of 5 on the bottom. So I put the square root of 5 on the top, and this number becomes 1. And anything times 1 is itself. So we're going to alter how the fraction looks, but we will not be changing its value. So the top becomes the top is kind of like 2 root 1 times 1 root 5. And when you multiply, you do outside times outside and inside times inside. So we get 2 root 5. And then in the bottom, we get the square root of 5 times the square root of 5, which is the square root of 25. And what is the square root of 25? Just 5. So whenever you multiply a square root by itself, the square root cancels, and the answer is just whatever's on the inside. And that is the answer. Now, that answer looks more complicated than the original, but that's how we, that is called rationalizing the denominator. That's how we get the square root out of the denominator. All right, let's look at another one of these. Okay. So I multiply the top by the square root of 6 and the bottom by the square root of 6. The top is 3 root 6 and the bottom is 6. Now, I can actually simplify this one a little bit further. You cannot simplify a number and a number inside a square root. So stuff on the inside of square roots can cancel stuff on the inside of square roots, but stuff on the outside can only cancel stuff on the outside. So we can't simplify here, but I can simplify there. And 3 goes into 6 2 times, so I get the square root of 6 over 2. Does that make sense? Do you want to see another one of those? Okay. All right. So I need to times the bottom by root 7 over root 7. Multiply those together, outside times outside, inside times inside, and I get the square root of 14. And on the bottom, the square roots cancel, and I just get 7. Can I simplify that further? Can I take a 7 from the outside and cancel it with a 7 on the inside? No. So that is as far as that one will go. All right. Okay. Here I have one square root minus another. Okay. We can put square roots together if they are exactly the same. So if I had 3x minus y plus 2x, these have the same, those are common terms, so I can put those two together, and I get 5 minus y. Okay? Or 5x minus y, sorry. So if I had square roots, like 2 root 3 minus 4 root 2 plus 6 root 3, these are common terms. They both have the square root of 3, and I can put those together using addition. So if I have 2 copies of the square root of 3, and I add 6 more copies of the square root of 3, then I get 8 times the square root of, do I say 6? 3. Good. Okay. So if the square roots are the same, then you can treat them like a variable and just add the outsides together. But in this problem, they're not the same. The square root of 63 does not match the square root of 28. So I'm going to factor both of those. 9 and 7, 3 and 3, 4 and 7, 2 and 2. So on the first one, I bring out a 3, and I leave a 7 on the inside. So 3 root 7. And then the next one, if I don't drop my stylus, I bring out a 2. What do I do with that 2? multiply it by what's already out there in 5. So I get minus 10, and the square root of 7 stays. Now, are those like terms? Yes. What is 10 root 7, what is 3 root 7 minus 10 root 7? Negative 7 root 7. Good job. Do you need to see another one of those? No? Okay. All right. If I had x to the 4th times x to the 5th, what would I do with those exponents? Add them together. When you're multiplying bases, you add the exponents if the bases have the same value. So that would be x to the 9th. So here, y to the 2/3 times y to the 2/7, we're just going to add 2/3 plus 2/7. What has to happen in order for us to be able to add fractions? Common denominator. What's the common denominator going to be? 21. What does this fraction need for the denominator to equal 21? 7 over 7. And this one is going to need 3 over 3. So 14 over 21 plus 6 over 21 is going to give us y to the 20th over 21. Okay? Same idea here. 75 is 3 times 5 times 5w, and 27 is 3 times 3 times 3w. Bring out a set of 5s, bring out a set of 3s. 5 root 3w minus 3 root 3w. 5 copies of the square root of 3w minus 3 copies of the square root of 3w would be 2 square root of 3w. The only difference there is they've thrown in a variable. Okay. Rationalize the denominator. I'm going to split this into the square root of 3 over the square root of 5. Root 5 over root 5. The top becomes root 15 and the bottom becomes 5. How do I simplify that? You don't. Good job. Oh, that's it. Okay. Get to work.